In this video, we're gonna talk about adding and subtracting radical expressions. In adding and subtracting radical expressions can be classified as like radicals and unlike radicals. If the radical expression have the same index and this radicand, then they are like radicals. So like radicals or radicals are called like radicals if they have the same index and the same radicand. So like for example, cube root of 2x, the negative 4 cube root of 2x, 10 cube root of 2x, and 1/2 cube root of 2x are examples of like radicals because they have the same index, which is 3. So this is the index, and the same radicand, which is 2x. So this is our radicand. Next, another example, square root of x squared, 3 square root of x, and negative 5 square root of 2x are examples of unlike radicals. So these expressions have different radicands, which are the x squared, the x, and the 2x, even though they have the same index. So when we say square root, the value of their index is 2. So they have the same index, but the radicand are different. So they are an example of unlike radicands. Now try to express the square root of 18, the square root of 50, and the square root of 72 as like radicals. As what you can see, they have the same index but different radicands. So how you are going to express that so that they become like radicals? Okay, let's start with the square root of 18. So the square root of 18, what are the factor, or what is the factor of 18 that has a perfect square? Of course, 9 times 2. Now get the square root of each factor. So square root of 9 times square root of 2, which is equal to 3 square root of 2. How about the square root of 50? So what is the factor of the square root of 50, which has a perfect square? So that is 25 times 2. So the square root of 25 times the square root of 2 is equal to 5 square root of 2. Next, how about the square root of 72? So for the square root of 72, we have square root of 36 times 2. And get the square root of each radicand. So 36 times the square root of 2, which is equal to 6 square root of 2. Okay, so that's it. And you can add and subtract radicals the same way you add and subtract, like learning using the distributive property. Okay, like for example, if you have 3 square root of 5 plus 7 square root of 5. So get the sum since they have the same radicand and the same index. So just simply add the base, which is 7 plus 3, So 10 times the square root of 5. So this is now the final answer. And how about this one? So the square root of 2 plus 6 square root of 2. Like what I said, 1 is invisible number, so we have 1 here. So 6 plus 1 is 7, and 7 times the square root of 2. Next, 12 square root of x minus 10 the square root of x. The radicals has the same index and the same radicand, so you simply subtract the base. So 12 minus 10 is 2 times the square root of x. So that's the answer. In adding and subtracting radical expressions or radicals, there is a rule, or there is a rule. Okay, in adding radicals, the rule is a, then the nth root of x, plus b, then the nth root of x is equal to a plus b times the nth root of x. And also the same in subtraction. So a, the nth root of x, minus b, the nth root of x is equal to a minus b times the nth root of x. So let's try to solve this. Let's have an example. Okay, combine the following radicals. First, negative 12 square root of 2 plus 4 square root of 2. So this is example of radical, or adding and subtracting radical expression. So as what you can see, the radicand and the index are the same. So we just simply add the base. So negative 12 plus 4, or using the rule, times square root of 2. So negative 12 plus 4, or minus, subtract the 12 and 4, then copy the sign of a larger number, so which is negative. So negative 12 plus 4 is negative 8 times the square root of 2, so it becomes negative 8 square root of 2. Next, another example, 3 square root of 3 minus 2 square root of 2 is equal to, 3 minus 2, this is times our radical, which is the square root of 2. So we have 3 minus 2 is 1 times square root of 2 is square root of 2. Remember that 1 is invisible number. Next, letter C. Or how about this one? Try to solve this. 5. Then the fifth root of 4 minus 3, the fifth root of 4, plus 6, the fifth root of 4. Okay, so again, just combine the base. So 5 minus 3 plus 6 times the fifth root of 4, which is equal to, so 5 minus 3 is 2, 2 plus 6 is 8, 8 times the fifth root of 4, we have 8 fifth root of 4. So this is now the final answer. So that's it. Okay, how about this one? Perform as indicated. Assume that all variables in the radicand are positive. So let's say 11 the square root of x, then plus 12 the square root of x. Okay, just the same as what we did. So 11 plus 12, they are an example of like radicals because the radicand, which is x, and the index, which is 2, is the same. Okay, so both radicand and the index are the same. Then square root of x, or times square root of x, so 12 plus 11 is 23 square root of x. So that is now the answer. Next, how about this one? Negative 2x, then cube root of ab minus 5x, then cube root of ab. Okay, is equal to, combine the base, so negative 2x minus 5x times the cube root of ab. Okay, so negative 2x minus 5x, we have negative 7x times the cube root of ab. So we have negative 7x, then the cube root of ab. Okay, so that's the final answer. Next, another example. What if we have 5a, then cube root of 6x squared plus a, then cube root of 6x squared minus 2a times the cube root of 6x squared. Okay, so again, combine. So 5a minus a minus 2a times the cube root of 6x squared. Next, 5a minus a. So the variable a has a base of 1 because 1 is invisible number. So 5 minus 1 is 4 minus 2. We have so 5 plus a, or 5 plus 1 is 6 minus 2a. So we have 4a times the cube root of 6x squared. So we have the 4a cube root of 6x squared, and that's the final answer. Now, how about adding and subtracting unlike radicals? So what are we going to do if the radicals are unlike? How are we going to add and subtract it? Okay, like for example, the square root of 50 plus the square root of 72. Okay, the first thing that we need to do is find the factor of the radicand that has a perfect square. So the factor of 50 is 25 times 2 plus the square root of 72 is, so the factor of 72 that has a perfect square is 36 times 2. So get the square root of the number of the factor that has a perfect square. So the square root of 25 is 5. Then square root of 2 plus the square root of 36 is 6. Then square root of 2. Since they are now like radicals, so we can add it by combining the base. So 5 plus 6 is 11 square root of 2. So that is now the final answer. Next, another example. 3, then the cube root of 54 minus the cube root of 16. Okay, so 3, then the cube root of, so what's the factor of 54? that one of each factor is a perfect cube. We have 27 times 2 minus the cube root of, so what's the factor of 16? Which one of the factor is perfect cube? Of course, 8 times 2. Now 3. So what's the square root or the cube root of 27? So a number that when you multiply by itself, the product is 27. Of course, we have 3 because 3 times 3 times 3 is 27. Then the square root of 2 minus. Now, what's the factor or what's the cube root of 8? We have 2, then the cube root of 2. Next, we have 9, the cube root of 2 minus 2, the cube root of 2. So 9 minus 2, we have 7. Then the cube root of 2. So this is now the final answer. Next example of adding and subtracting unlike radicals. How about this one? So 2, then the fourth root of 48x minus 4, then the fourth root of 243x. Okay, we are looking for the fourth root. Okay, 48x. So 2 times the fourth root of, now what's the factor of 48? That is a fourth root, of course, 16 times 3x minus 4. Then the fourth root of, what's the factor of 243? That is a perfect fourth root. Of course, 81 times 3x. Okay, so 2. So what's the fourth root of 16? The fourth root of 16 is 2 because 2, when you multiply 2 by itself 4 times, the product is 16. Next, the fourth root of 3x minus 4 times, what's the fourth root of 81? Of course, the fourth root of 81 is 3 because when you multiply 3 4 times by itself, the product is 81. And fourth root of 3x. Now simplify. 2 times 2, we have 4. Then the fourth root of 3x minus 4 times 3, we have 12. Then the fourth root of 3x. Now 4 minus 12, we have negative 8. Then the fourth root of 3x. Okay, so that's how to add and subtract the like and unlike radicals. So that's the end of my vlog. And do not forget to like, share, comment, and subscribe on my YouTube channel for more videos about mathematics.